simple and rather our first machine learning algorithm, which using which we will start predicting few things. So it is known as linear regression, and first I will try to give you an essence of what exactly it is, and then I will show you what is the mathematical proof behind this algorithm, how it exactly works. So let us start. Suppose we have our data points which we are plotting in x and y axis. What are our data points? Let we have some set of values of x and y, and let this be area of the house and price for that particular area. So we have some particular values of area, some particular values of price. We will feed all our values to our algorithm, and finally if the user wants to buy the house of a particular exact area, so what will be the price of that, our model should be able to predict. And we will assume that the area and price are having a linear relationship among them. This is our assumption for this algorithm. Now this algorithm can work not only in price and area, you can understand it can work on various other things which can tend to have a linear relationship that we will talk about later. So let us just understand. Suppose we have our data points spread like this. Now what we are going to do is we are going to find the best line fit which is passing through these. So if I draw two lines like this and ask you which is the best line fit, by eye estimation you can easily say that this is better, because this is far away from the data points and the error is much more here. So by eye estimation you can easily say that. But suppose the problem is, if I ask you for these data points, this line is better or this line is better? Can you say it by eye? Which slope of the line is better? Can you say it by eye estimation? Of course not. So we need to define some algorithm which we will use to add up all the errors basically. We will see what we will do exactly. We will just simply add or what? So we will first add up the error values. Whichever the error will be more, we will discard this, and the least error will be our best line fit. So what will be our best line fit? We may move the line little bit more or shift little bits up or down. We can think. So what will be the exact best line fit? So we will need to understand this algorithm. So first let us understand what is the particular error value. Let's say this is the point which our model will predict. This is the actual point, right? Corresponding to this, there is one x value. Let it be xi for the ith point. What is the exact value? Is yi. What our model is predicting? Let this line be y equals to mx plus c. This line. So what our model will be, this is our margin of error basically, right? So our model will be predicting something mxi plus c. This is what our model will predict. So our error is what? Our error is yi minus mxi plus c bracket. This is our error. So we need to minimize this error. So first we are going to add up across all the data points. So what will happen if I simply do summation? I want to get. What will happen? If I only do summation, suppose this value may be positive or negative depending on yi and xi. It may be positive and negative. So it may happen that this is the data point, this is the data point, this is the data point, this is the data point. Suppose this is equally positive, equally negative, equally positive, equally negative. All the points x1, x2, x3, x4, if we add, they are getting cancelled and getting to 0. And we are saying that we have 0 error. But do we have 0 error? We have so many errors, you can see. So what we can do, our basic intuition will be to add a mod here. Let us add a mod here. Now if you give a second thought on this, is this still correct? Is it correct? You give a second part. Suppose this is a line and these are the data points and this is another line on the same data point. You will see that if you do modulus, this minus this, the value will be this minus this, and this modulus will be the value of this minus this. So what will exactly happen? That if you shift the line between the same two data points, you will get that the modulus value is also coming same. So modulus will also not work. So we use something known as mean squared error, MSE. Mean squared error. What it says? It says that error will be equals to 1 by n. We will sum it, square it individually, and then sum, and then divide it by 1 by n also. This is our mean square error, and this is our basically cost function. What is cost function? Cost function is something. This much is our cost of our algorithm. This much is our error of our algorithm. We need to minimize this much of cost. So let us see how we will minimize this. So we will use some of our calculus knowledge to do that. You already know that differentiating or partial differentiating gives us maximum minimum of a curve, right? So you should be easily able to do this also. Let us assume this constant to be b instead of c. Why I did this? Because the cost function c we will write as something like this, mxi plus b, and this is also c, so I used it some different method, some different variable maybe. If we need to minimize this, suppose we are going to minimize this, it is sufficient to differentiate this much, because our variable are m and c which we need to determine. For a particular line y equal to mx plus b, we need to find m and b to exactly determine what is the line. So our aim is to calculate m and b. So what we will do, this is c as a function of m and b. This is c as a function of m and b, right? So what I will do, I will do partial derivative of c as a function of m and b with respect to b and equate it to 0. I will get one equation, equation 1. Then I will do partial derivative of c with respect to m and b with respect to just m and equate it to 0, and we will get equation 2. How many variables we have? We have m and b, 2 variables. How many equations we have? We have 2 equations to a variable. We can easily get out m and b. So I will suggest you to pause the video and try it yourself if you can solve these two. So let us just see how we can get to this. What will happen if we differentiate? So partial derivative with respect to b will be something like summation 2yi minus mxi plus b, isn't it? And partial derivative of with respect to b, so everything will cancel out, right? 2 into the inner derivative, if we do, it will remain minus 1 equals to 0. Okay? It will remain minus 1 equals to 0 because there is a negative here. So what is the summation? We can cancel out minus 2 from here easily. So summation yi minus m summation xi minus summation of b. There is nothing to iterate, so it will be simply n. And m, suppose there are n data points, so I will just write n here. So here also I summation of. Now what I can do is I can divide the entire thing by n. what will happen? Due to which this n and n will get cancelled out. If I remove this summation, can I write n? I equal to 1 to n. Can I write p into n? If I then this n and n will cancel out. Can I write this way? Y dot mean, yi dot mean. What is this? This is exactly the mean, right? This is the average. Sum of all values by n. This is the average. So minus m xi dot mean. You know that if it's a numpy array, we can find the mean this way, right? So it is b. So here we have one equation, the form of m, b. There are two variables. Similarly, we will get the other equation from which we can find, we can differentiate m, right? In the same way, you have to differentiate, and you can, I will suggest you to do that yourself. And there will be two equations, two variables. You can easily get to the answer. So that's all from this video, right? Now in the next video, I will talk about what exactly will these results be. I will give you the ready-made results from in the slides, and this is just for your information that our ML algorithm actually works in this way inside the computer. Now you don't need you need to code it out, right? You don't need to do all this calculation. It is the work of the computer to do all this. So it is just for your knowledge, just for your better knowledge, and if you do some advanced stuff, you may be requiring to understand these things. Otherwise, these are not very useful. Our work is to do the coding, the computer's work is to do the calculation, but it is advantageous if we know how exactly the computer works. Yeah. So yeah, that's all from this video. Thanks a lot.